Hey guys, I told you I'd make a video trying to just go over some things that we went over yesterday, and this is important. So I think if we missed anything yesterday, if after class today we're still a little confused and we want to kind of rewatch a lesson, I think this serves a lot of purposes. So thanks again for your patience yesterday. Just things are out of my control. The internet and just the different resources we have. So we're just going to make the most of it, figure things out as we go. So we talked yesterday about density curves, all right? And I think if you take a minute to read this page of the notes, it would be worth your time. All density curves have an area underneath of it which would equal 1, or in other words, 100%. All right, so whether it's 1 or 100%, that's the area underneath the curve. Now, normal distributions, all right, they're the bell-shaped curves. They're symmetric. They're the ones that we talked about yesterday. And in those types of distributions, the mean and the median are both in the middle. We've spent time this year talking about when distributions are skewed, that the mean gets pulled in the direction of the skewness, right? The mean is not resistant to outliers or extreme values, right? We also have talked about standard deviations and z-scores and talking about being above or below the mean. So normal distributions are going to allow us to do a lot of things. The first thing that we kind of, and the biggest at this point, the most important thing right now is we understand this concept of the 68, 95, and 99.7 rule. And these values right here, and I was impressed yesterday, a lot of us seem to kind of get the hang of it pretty quick, but 68, 99, 99.7 are going to allow us to work with 1, 2, or 3 standard deviations. We've talked about this little thing before, right? This is a Greek letter, all right? It's a population standard deviation symbol. And this is a Greek letter as well. It is simply just mu, which stands for mean, okay? All right, let's look at this example. All right, let's pretend that in a year, okay, all players in Major League Baseball had a mean batting average of 0.261 and a standard deviation of 0.034. And we're told that the distribution is exactly normal. So it's a normal distribution. And we're asked here in the first problem to sketch a normal density curve for the distribution of batting averages. Label the points. All right, well, I'm going to need that number right there, all right, the 261, and the standard deviation of 0.034. All right, when it says for us to sketch this curve, all right, we're going to try, just like we did yesterday, the best that we can. All right, we draw a horizontal axis, and then the curve goes up, comes back down, and we try to draw it as symmetrical as we can. Well, right here in the middle is going to be my mean, and that's 261. All right. Now I'm going to try to label as equidistant as I can 1, 2, and 3 standard deviations above, and 1, 2, 3 standard deviations below. Now I also have to label those points, those values that fall on 1, 2, and 3 standard deviations below. So take a second, think about the information that we were given again. All right, let me scroll back up here and show you. All right, 261 and 0.034. That's important. We're going to grab our calculators and we're going to add a standard deviation to the mean. So add 0.034 to 261. And don't just do it once, do it a second time, and finally do it a third time, okay? And the values that you would get if you added them would be 0.295. So that's this spot right here. We'd get 0.329 and finally 0.363. So that's 1, 2, 3 standard deviations above the mean. I'm now going to do the same thing below the mean. All right. I'm going to take my average of 261 and I'm going to subtract one standard deviation. Then I'm going to subtract the second and a third standard deviations, and I'm going to label those points. So that would be 0.227, 0.193, and finally 0.159. Okay. So if I were to ask you right now, all right, what's the batting average for a Major League Baseball player that was 2 standard deviations below the mean? You would simply just say, all right, here's the mean. 2 standard deviations below, it'd be 0.193. All right, so the first question just asked us to sketch the curve and label the points. We did that. Now it says what percent of the batting averages are above 329. So here's what I would do. I would sketch a curve, and maybe that would help me. I'd say, all right, here's my mean. And then I'd say, okay, well, 2 standard deviations, right? Because that's where 0.329 is. And above it. So maybe I'd shade if that would help me. Okay. But now I have to think, what percent is above? So in my mind right now, I know that 329, we talked about it yesterday, is 2 standard deviations. All right. And the value that goes with 2 standard deviations is this 95%. Well, when it says 95%, that rule speaks to the middle 95% of the data. All right. The middle 95%, everything in here, not what's in the tails. So if it's the middle 95, that means that there's 5% left in both tails, right? In the rightmost tail and the leftmost tail combined. This question just wants us to figure out the percent that's above, all right? The percent that's above 2 standard deviations, which means we would have to cut this number in half, and our answer would be 2.5%. All right? Again, it's not going to come right away. It's going to take some time. All right, we're going to do one more example here together, and then the video will come to an end. All right. It's not necessary, but I think it helps drawing the curve. Again, here's the mean in the middle, and we're asked what are the batting averages between 193 and 295. Well, 193 from our first answer in part A, we know is 2 standard deviations below the mean. 295, again, from our answer in part A, is 1 standard deviation above the mean. So in this question, we're asked what percent is between. In other words, what percentage of Major League Baseball players batted between 193 and 295 in this particular season? All right, so you have to figure out what makes the most sense for you. Again, in our minds, we have to understand the ins and outs of this rule. And some people yesterday that shared their answers, did it in a way that works for them. And there's going to be multiple ways here, and you just got to come up with the way that's you're most comfortable with. A few people yesterday said, if I cut this in half, that I'm going to now have 50% of the data on one side, 50% on the other. So let's think about this. If 0.295 goes with 1 standard deviation, which is 68%, but I just want this half, right? 1 standard deviation above the mean. If I was just focused on this area, right, the area that I'm coloring in darker right now, well, that area is half of 68. Or in other words, 34%. Over here, this area, well, it's 2 standard deviations. And 2 standard deviations, we know goes with 95%. But I don't want 2 above and 2 below. I'm just focused right now on the 2 standard deviations below the mean. Well, cut 95 in half, and we would get 47.5, which means from here to there is the sum of those two. All right, so my answer for this question is about 81.5%. All right. We're going to watch this video to start class today. And I think it's going to help us, and we'll continue to do some practice problems from there. All right, guys. Thanks.